Welcome. We're going to use the sketch, organize, solve method to solve for oscillations problems involving simple harmonic motion. So first in our sketch, we want to draw multiple states of our object's motion. We want to show that it oscillates. For each of these multiple states, we then want to draw free body diagrams for each drawn state. We want to figure out, which forces change and which forces are constant. So if we do this, we're also showing, that our acceleration changes. Once we have these free body diagrams, we want to draw graphs of our motion. So we want position versus time, velocity versus time, and acceleration versus time. And with these graphs, we want to label these graphs so we understand as much as we can from what we're given. So we want maximum positions or maximum measurements, initial phase, period. Whatever we're given, whatever we know, any sort of other things, we might have to do this back at the solve step, but we want all of these as much as we can when we start. In our organize step, we're going to start with Newton's second law again, that our acceleration is force 1 plus force 2 plus force 3, so on and so forth, over the mass. And then we are going to solve for the acceleration and we want it in terms of d squared x dt squared, d squared y dt squared, d squared of an angle dt squared, and how we want it. And then we want our second derivative in terms of the same variable. Once we have that, we also want to write all of our initial conditions so how this thing starts. So an example for this, x at time t equals 0 is 0, or velocity at time t equals 0 is the maximum velocity, things of this nature. So in our solve step, we have our simple harmonic equation which says if we can write a second derivative d squared s dt squared as equal to negative omega squared s, then our solution is s is a function of time is some maximum value of s times cosine of omega t plus a phase angle phi. And so if we had d squared y dt squared equals negative omega squared y, then we would have y of t. So whatever is the variable here, that is then our variable and our value here. So this gives us that, and then we want to use our initial conditions to find S max and the phase angle phi, and we want to use the second law to find omega in terms of what we've got from the forces. And then part of our solve step is that we want to complete our graphs from our sketch step. So with this, we can prove or disprove whether an object is in simple harmonic motion by looking at the forces and seeing if it satisfies the simple harmonic condition. If it does, then we can use the solution and we can use the initial conditions that we found, oftentimes easiest to visualize, and then put in terms of math, and then put in terms of solving to find all of our solution to the simple harmonic motion.